My name is Malcolm. On the forums, I go by Orbits, although these days I'm not super active on the forums. I've been using OCaml for, let's say, 15 to 20 years, and I kind of have solidified my style and the structure of my programs. So I just reuse the same 5 tricks over and over in every program I write. So I generally only come to the forums when I have some type error I can't figure out, or I'm trying to learn some new feature of a new release of OCaml. I don't know why OCaml became my daily driver. I think at the time I was at that point where you're just sort of trying every language out there, and OCaml stuck for some reason. But current me thinks that the reason I like OCaml so much is I think it hits the sweet spot between being very academically inclined, so a lot of the functionality and features have good theory behind them, they're really thought out, but it's also quite practical in that the implementations aim for being predictable, maintainable, and that really resonates and mirrors how I like to solve problems as well. I'm also the co-founder and CTO of Terrateam. So Terrateam is both a company and a product. The product is infrastructure management and orchestration. And while we work with anything that we can call through a CLI, really sort of most of our customers are using us to manage their infrastructure through Terraform and OpenTofu. And we're actually founding members of OpenTofu. And in particular, we're focused on GitOps workflows, where you manage your infrastructure through pull requests, and you get a lot of value out of that in terms of auditability, tracing what's going on, and so on, and review. Now, in the Terraform world, there's not actually a lot of guidance around how to organize your code, how to organize your repository, or any of that. And we felt from the beginning that we wanted potential customers to not have to change how they're doing things at all in order to use our product. We would try to mimic what their current workflow was and just add sort of a golden path on top of that. So flexibility was really at the core foundation of Terrateam. And as a result of that, we've sort of niched down into what are really tend to be complex infrastructure workflows, because you can configure the product to such a high degree. To level set where we are in the industry, if you include unearned wages due to working on Terrateam without drawing a salary, we have received about $500,000 US in funding. Our direct and largest competitor has received around $80 million worth of funding, and we are routinely evaluated alongside them by potential customers, and we win some of those contracts as well. As companies, nominally, they're still much larger than us, but if you use the amount of funding as a proxy, proportionally, we're doing way better than we should be. And OCaml, I wouldn't say it's our secret weapon here, in that if our competitors decided to use OCaml, they wouldn't achieve the benefits that we get from it. But really, I think for OCaml, if your mental model is sympathetic to OCaml's mental model, you can do a lot with very few resources. And that is the benefit for us. So we say no to frameworks inside Terrateam. And to be clear, I'm talking about external frameworks, as in dependencies. We have our own frameworks that we build and maintain. And a framework is a library that manages the control flow of your program. So if you've used something like list.map, you can consider that a mini framework. But really what I'm talking about here is things like Rails or Django, which are managing your entire application. At Terrateam, understanding is sort of when somebody gets onboarded, we put that as a top philosophical element of the company. And that includes understanding each other. We really pride ourselves on high-quality communication, understanding our customers, and what their needs are, but also understanding any code that goes into Terrateam. And that's because we are managing the infrastructure of our customers. So a bug in our software is a critical bug for our customers, because if they have an outage and the solution is to roll out a new infrastructure change, and we are blocking that, that is a serious issue. So because of that, we want to understand any change we put into our product and have a lot of control over what that change is doing. And frameworks come in conflict with that, because if you consider pretty much any successful community-led framework, it's going to have a lot of functionality, because as the community grows, the use cases of the community grow with it, and it wants to cover all of those. So certainly you can understand all the code and external dependency that you want to use if you want to. But if software quality is important to you, that's a risk you have to mitigate somehow. And the path that we chose was through maintaining our own frameworks for these core things that impact the control flow of our program. There's a great Joel Spolsky blog post in defense of Not Invented Here. And the Microsoft Excel team is used as an example of some of the benefits you can achieve when you're rewriting a lot of code. And Not Invented Here generally has a bad reputation. So if you ask about it on the internet, they will say, you should be focusing on what differentiates your product, and rewriting a lot of existing functionality is not what differentiates your product, so don't do it. The Microsoft Excel team had a motto of find the dependencies and eliminate them. And if you believe the blog post, the argument here is that the Excel team was able to accomplish a lot of things that other teams couldn't, because by owning all of what would be dependencies for other teams, they had a very high code quality. They lacked any sort of impedance mismatch between their dependencies, so they could move quite quickly and accomplish things that were not possible for other teams. And so this isn't scientific or anything, just my feelings, but I really agree with this sentiment. Of course, context matters a lot, but I think the software industry tends to be a little too liberal with which dependencies it pulls in and how many of them. And for me, I see a lot of benefit that indirectly ends up impacting your ability to ship a differentiated product. So obviously, if one group of people is implementing all of the functionality, then you're going to have a consistency amongst your code and similar code quality. And all of that functionality is going to come from sort of the same mindset and view on how it should be structured. And you end up getting, in my opinion, a consistency that once you hit a critical mass of functionality, you can start adding more functionality faster, because all of your dependencies are working together rather than trying to get something from over here to work with something from over there. Now, there's no solutions, only trade-offs, of course. In our case, we had the ability to have time to do a lot of this. But in some situations, if you don't have that situation, you don't have the time to implement a lot of your own dependencies, this isn't a great option. And like I said, I think the software industry in general is pretty liberal with dependencies. And I think if you're doing something different than what the general software industry is doing, there's probably a cause for that. And so for me, that's two things. One of them was a project that was written in Django and Angular that I had to manage. And it was pure misery for me. I don't think how the Django authors think. Django is really designed to have a request and response workflow. So if you want to do background work that was kicked off by some request, you can do that, but you're kind of going outside what the framework was really designed for. It has an ORM that is, if it's producing SQL, that's not very performant. It's kind of a black box there. And because of all this meta programming magic that goes on in Django, if you want to understand what it's doing in order to track down a bug, you end up having to really understand a lot of the Django code. So even though we weren't writing the Django framework, we ended up having to effectively own it and read so much of it that there wasn't a significant difference between these two situations. Angular was a similar thing, although with Angular at the time, it was changing quite a bit between releases. So when a new version of Angular came out, they dumped maybe like a week from 1 to 3 weeks in your lap of just work you had to do that they decided is now on your plate. And you have to upgrade at some point in time. So whether you spend that time now or later, it's still 1 to 3 weeks. And these versions of Angular were also not making great use of the type system, so you didn't really have any help in doing these big refactorings. So for me, this led me to be very conservative in not getting caught up in the vision of another project. I didn't want the framework developers that are controlling so much of my application's flow to diverge from what I wanted to do. And just making my life harder because of that. The second part is at least how I would characterize the OCaml culture that I grew up in is sort of rugged individualism. There are how many standard libraries? There are how many concurrency frameworks? There's one more that's going to be brought up here. How many of like companion cubes libraries are the same thing that already exist, but they're just how he thinks it should be done? And I think this is just part of, maybe it's shifting now, I don't really know, but I think this is just part of how like OCaml developers think and work. And personally, I like it. As long as the community is large enough that we can get new compiler releases with new cool functionality in it, I really like the creativity and the ability to, the willingness OCaml developers have in reinventing the same thing just with their take on it. In some sense, maybe OCaml suffers from being too expressive, but again, this is like a culture that I actually appreciate. So while we say no to external frameworks, we are saying yes to libraries in a lot of cases. And the reality is, so I'm talking about frameworks and libraries, but the reality is that these are proxies for more like declarative components and stateful components, where frameworks tend to be quite stateful. And we see a lot less risk in declarative components, so that's a lot of libraries. In particular, with declarative components, as long as your interfaces match, you can flip out one for the other without it impacting your application too much. They tend to have a much narrower focus, so bugs end up just being sort of like less rare, mostly because the surface area is a lot smaller for declarative components. But stateful components are managing a lot more of your application, and we all know state is where all bugs come from. So we actually use like a lot of Daniel Winsley libraries. We're big containers users and all that. So it's not that we are completely inside our own world where we've written everything. We do consume certain types of things based on what risks we want to have. So some context in terms of what our environment looks like. We actually have more code in the repository, but it's auto-generated, and for various reasons, we check that in. So the amount of code that an actual human will interact with is around 106,000 lines of code. Most of that's OCaml. There's a little bit of JavaScript or TypeScript in there, and a smidge of Rust. That's across around 1,500 files, and 192 packages, where a package is something that you use, that you link against using OCaml find, and 4 authors. Everything is open source, and you can see it on GitHub. So there's a distinction between abstractly thinking that these external frameworks and dependencies are not something you necessarily want in the core of your application, and then actually acting on that. So for me, this is the earliest commit I could find, was in 2013, where I started first writing all of what is now what runs Terrateam. This ends up becoming what we call ABB, or asynchronous building blocks. And with the caveat being, this was so long ago, I don't 100% remember, and so I could be wrong in some of these details. The origin story here is that I was using async quite a bit at the time, and I wanted KQ support because I was developing on FreeBSD. And I went to add it, and it was just a bunch of work. It was like surprisingly more work than I expected it to be. And then, so with this blocker of, do I actually want to invest this much time in that? I started thinking about async and LWT and like what other things I didn't like about them, and then ended up convincing myself that like, well, why don't I just rewrite it myself anyways? So in particular, what I did not like about async and LWT at the time was you could not write this function abort after, where you have some asynchronous option you want to do, and if it's not completed in a certain amount of time, you can cancel it and get all those resources back. I came from an Erlang world where it's very common to just spin up tons of work, and then when it failed for some reason or you just need any more, you would just terminate the whole thing, and your whole dependency tree goes with it, and you get those resources back. Additionally, we're doing async programming because we want to maximize our resource utilization. So it only makes sense to me that if I'm trying to accomplish this, I should be able to get those resources back when I no longer need them. So I really wanted this, the ability to program with this style where generically you can just sort of cancel work. So I thought, how hard could it be? ABB was born somewhat out of I'll say it's 2 parts challenge and then 1 part experimentation. It was a personal project I wanted to do for fun, and I was also working at another job at the time where I was writing a lot of Python and Java, and I just needed another software-related creative outlet so that I just wasn't enjoying writing Python and Java. So I wanted this other outlet. And I didn't really care at all if anyone used it. This was just for me. This was for my own learning. And I wanted to, if I was successful, I would just use this to write programs for myself. So from that beginning, this is where we are today in terms of functionality that exists. We have a comprehensive test suite. We have a concurrency framework with cancellation, and then all these sort of standard components that you would expect. This does not include any of the Terrateam specific components that we developed as well. All these are our generic components. So we've come pretty far. And in this, with this, I've written obviously Terrateam, but also I have a bunch of personal apps I've written as well. I have a podcast player and a few other mobile/web apps written in this. So it's been handling quite a bit of use cases for me. So it's really hard to evaluate how the quality of decisions. It's hard to measure productivity. So I'll try my best to say how I think this is actually going for us with the obvious bias that I'll have towards this, because this was a decision I made, and it's a decision I put a lot of time into. Like I said, that first commit was 2013, so that's 12 years ago. And I'll do my best across 3 areas. The first one is velocity, the second one is quality, and the third one is hiring. So in terms of velocity, from whenever I made this slide, I just looked back for the previous week inside of our support Slack channel. And between partners and customers, it's pretty common that people are impressed with how fast we can ship both bug fixes and new features. This one from the middle, incredible speed, was actually from a partner that wanted a new feature, and we shipped it in a week, and the partner was really surprised, and they said we had a pool going internally that would, whether it would be 2 or 3 months before you shipped it. And a lot of this speed, again, comes from what I talked about before, where all of our libraries are meant to work together. So adding a new feature is really building upon this suite of libraries that are already designed to, hold hands with each other. But the feedback is consistent in that we are doing things pretty quickly. Quality, this one I'm going to be even more biased on, of course, because I wrote a huge chunk of all of these frameworks and libraries. And it's also really hard to measure quality. So I tried to find a few measurements that maybe are more objective. One is that when bugs are reported, they're almost always solved within 1 to 2 days of being reported, and almost always with less than 10 lines of code change to resolve the bug. 2 is that I looked at every file, every source code file that we have under management, and the median number of commits per file was 2 commits, with the maximum number of commits per file being 87. Now, that's not entirely fair, because that file that had 87, that's the third version of that module that we've written. So I lost however many other commits there were. So we do have some modules that we rewrite a few times because we didn't think we got it right. But in general, if you take all that 1,500 files, most of them are not being modified that much after they're created. In general, we go through what I'll say are quality cycles, where we might have a bunch of functionality that we want to prioritize going fast on deploying, and we're willing to sacrifice quality for that. And then after we feel like we're stable there, we switch back and try to increase the quality and all that. Also, I think being a monorepo with all of our software in one spot is really important to quality, in that if you're adding a feature and you come across a low-level library that you think, you see a function, you think I can make this function a bit better, I can add a comment to this function to make it more understandable, or anything like that. Since everything is accessible, you don't have to, if you modify something low level, you don't have to update a bunch of dependencies along the way. It means it's much easier to actually keep on increasing the quality of every file there. So I think that's, in our case, the monorepo is kind of our secret weapon in code quality. In general, I think I'm personally pretty happy with the quality of our code. Finally, hiring. I have very little to offer on the hiring front. We are a small company that wants to stay small. I think if you ask Reddit about choosing a tech stack and and building a company, what should I do? A lot of people on the internet will say things like, well, you want to make sure that whatever you choose has a lot of people to hire from. I think those answers are kind of useless, in the sense of you need to first start with what kind of company you want to have. So since we want to stay small, we could effectively choose any language except for maybe brainfuck or something like that. The hiring pools for most esoteric languages, around OCaml and up, are totally large enough for all of us, for our company. When we decided to grow, it was one of the easiest experiences we had. There was a pool of very capable OCaml developers just dying to find an OCaml job. So really, if you want to be a big tech company, I think those answers that you'll find might be good answers. But if you want to stay just a reasonably sized company, I think you have a lot of leeway in what technology choices you can make. So I just want to be really explicit for, I don't want someone to hear this talk and then go back to their manager and say, well, Terrateam uses OCaml, or they build their own frameworks, we should do that as well. That's not really what this is about. We started Terrateam 3 years ago officially, and so that means I had 9 years to build up all of these frameworks on my own and put them into a state where I thought they were production ready. If we did not have those frameworks today and we decided to start Terrateam, I would not push to spend the first 9 years of the company building all that stuff out. Maybe we would have a path where we started with existing things and then started replacing them with our home-built ones as necessary if we wanted to. But definitely, we were in a position where we could benefit from being able to do this. So really, I think you should design around what your goals of your product and company are. You should try to mitigate risks. If you have certain things where are incredibly important to get right, maybe try to own those things. But if just moving fast is what you're after in your product, like that's how you're going to succeed, then while there is a benefit in the long run to building a lot of your own stuff, in the short run, that benefit doesn't exist, so that might not be necessary. But really, I think for me, one of the most important things is there's a huge time between when you first have a product idea and when you first start getting your revenue from that product idea. So you should really try to focus on making decisions that will keep you excited to solve problems along that way. For me, that's using OCaml and using our own frameworks. Like even if I'm solving a mundane problem, I enjoy the act of testing what we've built against all those situations, and so that keeps me excited. Thank you very much.
Thank you, Malcolm. And yeah, just like you are you have so much well manners, but I will mention that that this project is open source on GitHub, and they lack a few stars to 1,000. So just go and start it right now. And here is one of the first.
Hello, thanks for a nice talk. Do you use OCaml 4 or do you use OCaml 5 in ABT, or however your concurrency framework is named?
We were OCaml 4 up until like 2 months ago, and I increased the version to 5, and everything worked.
And also the performance and memory usage is fine?
We aren't pushing it like some people in this room are, so we haven't experienced any issues and no regressions in that regard. The main actual instigator for switching to 5 was we had just some CPU-bound work that we actually wanted to do on another core, so I wanted domains. So we upgraded to 5, and then I switched our thread pool from doing thread.whatever to domain.whatever, and then done.
Cool, thanks.
Any more questions? Did I miss someone? Okay. But, oh, yeah, I see.
You mentioned that different libraries work together. Could you give like an example of that?
So for us, we have this ABB suite, and from there we have concurrency monad, we have HTTP libraries and Postgres libraries and all that. And all those are designed around like cancellation working correctly and cleaning up resources, being able to communicate via channels inside of our application and all that. So all of those are built along the same like philosophy and foundation and types.
Okay.
Oh, okay. We have any more questions? Yeah. Okay.
You said you do use some libraries. Do you have like any criteria for when you'll use like an external library as opposed to building your own out?
Yeah, well, so libraries in general, like I said, we're much more open to using, and usually it's around if it's something I consider really boring and uninteresting. So like we use like the ISO whatever date library quite a bit. A bunch of the stuff Daniel Winsley does is around like these certain interfaces, which I just like have no interest, and I also completely trust him to write a high quality library. There are a few things like we wanted to do some very specific sort of string templating. So we actually wrote that library, which was actually quite short, but we just had like specific semantics we wanted to do to match actually how like the Python string template library works. So it's that sort of thing we did right internally. It definitely sort of comes like at this sort of like mental estimation of how likely I am to get it wrong if I try to do it myself, which is like a big weight in deciding to do an external thing too.
Yeah, because it sounds like your point about it being stuff that you're excited to work on is like a really big factor.
Yeah.
Thank you.
How do you find writing your own libraries, like, I guess, running into like weird, obscure bugs? Because I feel like whenever I use like open source libraries, like, you know, say co-HTTP, it's nice because I'll run into an issue and I'm like, okay, there's already an issue open. There's already work being like done on it by like the open source community. And I guess like how do you balance like the benefit you get from the open source community contributing to libraries versus writing them yourself and not getting that benefit?
I guess my experience is often that there is a ticket and no one's working on it, so I feel really frustrated. So in this world, I actually feel much more empowered just to solve the problem. I don't have to worry about if how I solve the problem aligns with like the library's founder and their vision. So we certainly have had like low-level difficult to fix libraries inside of our frameworks, but they've actually been much fewer than you would expect given the scope of what we've solved. And I do think it's important to point out that we are not really performance bound for a lot of stuff that we have. So we can have like the naive implementation that is, for the most part, easy to read and easy to work with. And that works fine for us. And that tends to be like a real strength, I think.
Thank you.
Okay, great. Thanks, Malcolm. First, like round for applause for Malcolm.
Thank you.